Oh, this is a joint work with Bettina Fazzinga and Sergio Flesca, who are with the same institute as mine, University of Calabria. Well, before presenting the contribution of this work, I will introduce just some preliminaries, assuming that you are all familiar with abstract argumentation frameworks, AAFs. Well, attacking complete AAFs are a generalization where, besides the traditional sets A and D of certain arguments and attacks, we are also given a distinguished set, D question mark of uncertain attacks. So the point is that while certain arguments and attacks are definitely known to occur in the argumentation, the same does not hold for uncertain attacks because there is no guarantee that they will occur in the argumentation. This way, attacking complete AAFs encode in a compact form a set of scenarios for the argumentation, in the sense that each scenario corresponds to a specific combination of the uncertain attacks. Formally speaking, each scenario is called completion, and it is a standard AAF containing all the certain arguments and attacks, but also a subset of the uncertain attacks. I-star extensions are the natural adaptation of the notion of extension to this context. But here, in attacking complete AFs, we have multiple scenarios, so we can adopt both possible and necessary perspective. So possible I-star extension is a set S that is a possible, that is an extension in at least one completion. And for the necessary perspective, you just have to replace at least with every. So this is an example. Assume that you are given these three certain arguments A, B, C. Well, in this case, assume that all the attacks are uncertain. So we have 2 up to 3, that is 8 possible completions. F1 contains no attacks. F2 contains the attack from B to A. Then this one, the attacks from A to B, and so on. Obviously, they are in no particular order. Now, the point is that if you look into these completions, you can see that every subset in this case of the arguments is a possible admissible extension, because in the first completion, there are no attacks, so every set is admissible. Under necessary perspective, only the empty set and the singleton C are extensions, because you can see that C is never attacked by any other argument. So in the literature, attacking complete AFs and more in general incomplete AFs, where the uncertainty can affect also the arguments, have been widely studied. What we know is that under the admissible, stable, complete, and grounded semantics, introducing this form of uncertainty does not increase the computational complexity of checking I-star extensions. This does not hold for the preferred semantics, because here the complexity explodes. So what do we do in this work? Well, we start from attacking complete AAFs, and we investigate what happens if we resort to specifying correlations between the uncertain attacks. So just a motivating example, assume that we are given the same attacking complete AF as before, but now we know that this attacking complete AF comes from merging 2 subjective views. That is, we have 2 groups of people, A and B, whose members have antithetical political standpoints. So assume that A is claimed by members of A and B by members of B. So it's plausible that members of B will see the attack from B to A, and members of A, the attack from A to B. So depending on the considered standpoint, exactly one of these attacks will occur in the argumentation. And this corresponds to a kind of a choice dependency between these 2 attacks. That is, exactly one of them will occur. Analogously, assume that the motivations underlying the attack from B to A imply the existence of an attack from C to B, though, so there is an implication dependency between these 2 attacks. This is this has some impact on the reasoning because after you specify dependencies, some of the completions that we have seen before are no more valid because they violate the choice dependencies, so they are impossible scenarios. For instance, all these completions are not valid with respect to the choice dependency because they contain no attack between B and A, or they contain both these attacks. Analogously, these completions violate the implication dependency because you can see that they have the attack from B to A, but not the attack from C to B. So these are the only valid completions. And obviously, if you restrict your reasoning by considering only these valid completions instead of all the possible completions, the outcome of the reasoning is different because, for instance, under the possible semantics, you can see that the singleton B or the set AB are no more admissible I-star extensions. So we use as a language for specifying correlations, a language based on dependencies. So each correlation is expressed by means of or, NAND, choice operator, that is a monadic operator taking as argument a set of attacks. For instance, or X means that at least one attack in X must occur. NAND means that the end must be false. And choice means that exactly one of the attacks must occur. Moreover, we consider a general form of implication. X implies Y means that if all the attacks in X occur, then at least one in Y must occur. That is a form of disjunction. Then, given a set of dependencies, we say that a completion is valid if it satisfies all the dependencies in this set. Given this, we introduce attacking complete AAFs with dependencies as an attacking complete AAFs where we associate a set of dependencies. Then we use only valid completions to back the reasoning. So I-star extensions are defined as before, but here only valid completions are used to witness or as counter witnesses of the fact that a set is a possible or a necessary I-star extension. So a first proposition setting a general property about the impact of the presence of correlation is this, that is, as long as you add more and more dependencies to the attacking complete AAFs, the set of possible extensions shrinks, while the set of necessary extensions grows. In other words, this means if you add dependencies, this can change the status of a set test, because if it was an extension, it may not be more an extension. While if it was not an extension, it can, under the necessary perspective, it can become an extension. So in the setting, we study the fundamental verification problem. That is, we have to decide if a given set of arguments is or not an I-star extension. And in order to, we address the computational complexity of this problem. And we perform a thorough study where we try to isolate the sources of complexity. So we study the sensitivity of the complexity to the forms of dependencies that are used. And we also consider possible syntactic restrictions. For instance, we see what happens if you allow only binary or NAND choice. And for the implication, we call M and N the cardinalities of the left-hand side and the right-hand side of the implications. So this is a synopsis of our result. The first row is the literature. It says that if you specify no dependency, but you have some uncertainty of some attacks, then this is the computational complexity of verifying extensions. So our results are these ones. So first, under the preferred extensions, under preferred semantics, nothing changes. Under complete and grounded semantics, the computational complexity explodes independently from the form of correlation that you use. The problem from polynomial time solvable becomes NP complete. things are more intricate and, let me say that, more intriguing when the semantics is admissible or stable. If you use or dependencies of any array, the problem is still polynomial. While if you use an AND and choice dependencies, if you restrict them to the binary variants, the problem becomes NP-complete. As for the implication, well, the point is that if you restrict the left-hand side of the implication to one, that is, you use just one implicant, the problem is polynomial, even if you use the disjunction on the right-hand side of the implication. But if you allow at least two elements on the left-hand side of the implication, even if you do not use this disjunction, the problem is NP-complete. We also consider the combination of the two polynomial time cases, and we see that if you use both or and the implication, the problem is still polynomial, while any other combination of the forms of dependencies listed above leads to NP-completeness. So in conclusion, recently we presented at IGCAI a similar paper, but there we considered the dual problem under argument incompleteness. Very briefly, if you compare these two papers, you'll notice that when the completeness affects the attacks rather than the arguments, generally reasoning is more complex. As a future work, we will characterize the complexity of the replication problem under the necessary perspective, because all these results are valid only under the possible perspective. And we aim at unifying the frameworks of this paper in the IGCAI ones. So thank you for listening to me. I hope you enjoyed this talk, and I'm looking forward to hearing your questions.